Hello, Slew members, and welcome to the latest Clubhouse show. I'm Eric Edelman, the producer here, and I'm coming to you live from Smoky Hollow Studios at Slew HQ in Washington Depot, Connecticut. But tonight, we're looking at a point in the sky from a place on Earth that's a little bit different from where we've usually been going. We've been in the northern hemisphere with the Canary Islands, but now we're traveling south. So this might be a unique sky view for people that have seen the recent shows. We're going live from the Slew Chile scopes to look at a very, very, I say unique, but interestingly similar to our own stellar system. And so that's going to be a lot of fun tonight, and we might as well get started. Tonight, I am joined by Slew astronomer Bob Berman, and we're going to go deep into space and see what's out there that's like us and unlike us. So welcome, Bob. Thanks for joining us tonight.
Oh, it's a pleasure. So exciting to be here when we've got all the telescopes firing and a great night and amazing object in view. This is, wow, it's exciting.
Yeah, so where exactly are we looking today? We have here's our all sky, but where are we going to be pointing tonight?
I know this was so funny. Before we were on air, I was looking at this. I know the sky pretty darn well, and I was saying, "What? What's those bright stars on the left? What is that?" It's like I'm 8 years old and I'm starting with astronomy all over again. And then Eric said, "This is the southern hemisphere view. This is Chile." So instead of our all sky view from the Canary Islands in the northern hemisphere, we've got a Chile all sky, which means that right in the dead center near the bottom is the Southern Cross, the famed Southern Cross. Yeah, there it is: top star, bottom star, left star, alpha, beta, gamma of Crucis. To the left of that is the famous Alpha Centauri, the closest star to us. That bright star there, Alpha Centauri, with Beta Centauri to its right, but no one cares about Beta. Alpha, 4.3 light years, closest star to Earth. And look at the Milky Way running all along it, all the way to the left. And that's where our focus is going to be, on the left side, because there is the constellation of Scorpius. Those two bright stars are Saturn on the top, which is right just about in the claws of the scorpion. Right under that is Antares, the famous red supergiant. And then below that, there's the tail of the scorpion curving down, ending with the star Lambda Scorpii. And to its left, that bright patch of the Milky Way, that's the center of our galaxy, the spot around which everything in the night sky revolves, unless you count the Andromeda galaxy. But everything is visible to the naked eye, except for Andromeda, goes around that spot every 240 million years. And that's where we're going to be focusing tonight.
And we're actually getting in live views now of the spot that we're looking at here. Here is a live view coming in. I believe that this bright one may be our star, or maybe near our star here, which is the, yeah, we are looking at HD 115600 for those of you who like to speak in the HD catalog. And
Yeah, that's
it's
right. These aren't. This is, we're not using the ancient classical name like like Arcturus or Vega. We're not using even the Bayer designations like Beta Leonis or Gamma Arietis. No, once you get to the HD and the HDE catalogs, you're looking at fainter stars. And the fact that there's so many of them in the field of view, we saw in our wider field view, the star field is flooded with stars right away, Eric. That tells us where we're looking. Because if we were looking towards, let's say, Virgo or Ursa Major, the Big Dipper, you'd only see a few stars in the field because there's only a few other suns between us and the yawning emptiness of intergalactic space. But my goodness, look at this in this Slew live from Chile starfield. There's no end to it. There's fainter ones behind the brighter ones and fainter ones behind that. And when you see that, you know you're looking at in the direction of our galactic plane. And in that direction, here's today's discovery.
we have really quite an interesting star to talk about, and so we saw it live through the Canary Island scopes, but we also have some astronomers that are looking through these things with the 10-50 minute exposures and looking at them through very large telescopes to see some very interesting things. Though we see in the center here that the star that we're supposed to be looking at is sort of blocked out to show us another very, very interesting thing surrounding the star. Like what are these blues and reds? Like what
Uh,
exactly are we
It's
looking at
so
there?
cool. It's so cool. Multiple wavelengths, and this is a false color view to bring us this ring. You know, it's appropriate because this month that just passed brought Saturn at its closest to Earth. Many SLU members are watching Saturn. It hasn't looked this good in about 7 years, with the rings now angled beautifully. But here's a deep space version of Saturn. Here we're looking way past our solar system to essentially a ring, but it's a ring that's evocative of the Kuiper Belt ring around our sun. In other words, look at the scale. At the bottom, we've drawn this for you, Sun to Pluto shown on this scale. So this is way bigger than even the distance from our sun to Pluto, the poor demoted exoplanet Pluto. And beyond Pluto lies the Kuiper Belt of icy debris that we think was part of the origin of the solar system. So here we're seeing the same thing with another star, a ring, a protoplanetary ring of a new baby solar system that's forming. And this is a crowded region. It's called an OB association. And this is the Scorpius Sagittarius OB association. And right among them is a star a little bit more massive than our sun, 1.4 times the weight of the sun, solar type star. Our sun is a G, this is an F, which means normally actually the Fs are a little less massive, but you know they come in all flavors. They come in super giant, slight giant, Roman numerals. You remember this from school, Eric? Roman numerals 2 and 3 and 4. Our sun is a Roman numeral 5. We don't want to put everybody to sleep with this, but the idea is this is a almost a sun type star, a little bit more massive, and surrounding it is a ring of material that newborn planets will probably condense out of. So it's a little evocative of our own past.
So is this this material that's surrounding this star? Do we not have that anymore? Is that not a part of our solar system?
No, that's still there. The Kuiper Belt objects. In fact, Pluto is probably a Kuiper Belt member, along with all the other flotsam and jetsam out there with names like Maki and Haumea and Karen and Iris. And so there's a lot of other bodies, some named, some explored, most unknown, that are still out there surrounding our own sun, way in the distance, mostly made of ices. Well, same thing here, silicates, ices, really similar to our own solar system. And it's always great to look out and see that what's going on or went on 4.5 billion years ago here is being repeated. You know, it's a there's still new birth taking place in the universe, and you know that's a lovely story. Except, of course, the lives of stars. A different time scale than the little misadventures that you and I get into, Eric, and the rest of us, the rest of our SLU members. So, very deep and profound and beautiful and lovely and poetic as well as being scientific.
It seems so amazing that we're seeing just similar distances in terms of how far our planetary bodies go out to what we're seeing in terms of the length of this disk. And I mean, it brings to question: is there sort of a uniformity among sort of stars of similar type? Do they have similar formation scenarios? And I just think there's so much that we can learn from this. In particular, I was wondering, Bob, is there anything you'd like to see us learn about the formation of our solar system as we're looking at examples out there in the distance?
Well, yes, and the first question that comes to mind is whether we always go back to life, of course, because we are life, we're consciousness. How frequent would that be? And when we find Earth-type planets, Sun-type stars, that's one of the first things that comes to mind, even around relatively faint stars such as this. I know some of our members may be wondering what kind of a star name is HD. Well, it's one of the catalogs. You know, if we don't if we're not looking at a bright star with a popular name like Vega or Arcturus, then there are other names, and then you get to catalog names HDE, HD, and then you're looking at the universe of fainter stars. And when we look in this direction, as we are here at SLU, live, looking towards the center of our galaxy. There are so many, there's 400 billion stars known just in our own galaxy. And we see more than have even been named and cataloged when we look in this direction. This is great. Our all sky view, this is not to be taken lightly either from Chile. I love that the Milky Way is running horizontally across the sky. We don't see that here from Canary or from the northern hemisphere, running straight across in the direction of Sirius on the right, the Southern Cross right lower center. And actually, if you go up to the dark region just above center, there's a quadrangle. There's a curious, that's it, curious little quadrangle, which is Corvus the Crow. Good luck making a crow out of that quadrangle of stars with the star Vega to, I'm sorry, Spica to its left, which is the brightest star of Virgo. Yes, Spica, blue star. But if you drop a stone, a plumb bob, straight down from Corvus the Crow, that quadrangle, that's how you find the Southern Cross. Now, when you go out these nights, you'll see that at about 10 p.m. local time. You'll see Corvus looking like that quadrangle, and look below it, and look below it, and way down, what you'll come to is the southern horizon. You won't be able to see any further. But here in our Chile telescope, the southern horizon has dropped down because it's so far south, south of the equator, of course, that now you see what's beneath Virgo and Corvus the Crow. And you see that always just south of Corvus, that's where you find the most famous southern constellation, smallest of the 88 constellations, and also brightest, since it's got 3 zero magnitude stars among those 4 stars that makes up the famous cross. Only the one on the upper right, Delta Crucis, is fainter than the others. Gorgeous. And then to its left, we started out saying it, but that brightmost star way to the left of the cross, or some distance to the left of the cross, is the closest star to us, Alpha of the constellation Centaurus. So that's really cool. And then on the way left of the star field, these are live views we're seeing. That smudginess on the extreme lower left, that's the center of the galaxy. And that's the direction that we're facing here. That's the spot around which we revolve. And so does everything else in the universe. It's located 26,000 light years away, and we don't actually get to see the center because there's so much dusty gas blocking it. We see a few thousand light years, and then it's blocked. Fortunately, infrared telescopes and some of the radio noise we get at 21 centimeters tells us the structure and shows us what's behind that kind of Beijing level, smoggy, dusty, impossible particle, dusty. Most of it is a lot of carbon particles too. So this is a great view. It's very exciting.
It really is, and just it's so different than what we're seeing in the northern hemisphere all the time, and it brings to mind that a lot of us are locked into one hemisphere or another, and it's great that we can share both skies here live, and it's something that we love to do if in particular if there's a event that's going on that we can see both from the northern and southern hemispheres. That's a lot of fun to bring to light, and it's actually something that we're going to be doing very soon here on SLU in those that are looking forward to the June solstice. Well, we have the sun from the northern and the southern hemisphere that are going to be coming to you live, which is something to look forward to. So if you are from one hemisphere and are missing the other, maybe you might consider tuning in. uh, but alongside with that, we have a lot of fun things coming up. One of them in particular this coming week is going to be Uranus is going to be photobombed by the moon. That's coming up just this Thursday. And that's going to be coming from also the southern hemisphere. There's going to be a bit of a trend this week and coming into the next of looking at some of these objects from down under, which is, it's a
That
unique perspective. It's a unique view.
I'd love to hear our members and even the new members and people who are just starting with astronomy, but perhaps especially those who've had a long experience, kind of vote or tell us their favorite celestial objects of both hemispheres. Now, of course, we're not talking about solar system objects, which following the zodiac take turns spending half the time above the Earth's northern hemisphere and half the time above the south. No, because they're not permanently north or south. We're talking about the deep space objects like what we looked at tonight. What are your favorites? For example, the Andromeda Galaxy and the Seven Sisters, the Pleiades, are in the north. The fantastic globular clusters of the south, 47 Tucani and Omega Centauri, are the most amazing cities of suns in all the universe. They're strictly in the far southern hemisphere. What are yours? What do you like that's above Australia, and what do you like that's above the United States and Europe? It would be interesting to hear your views.
That's I am totally on board with that, really. And if you don't know sort of what's in which hemisphere, then maybe this is the time to explore, since you're in and around SLU. Like we have, what's up this week, updated recommendations for what to look at the night sky, what's good in in terms of planets, in terms of deep sky objects, in terms of whatever you want to look at in either hemisphere. See, we have this easy division: Canary Islands, Chile. You can also think of it as north and south in some ways, and seeing sort of the sky charts of what's up, and the highlights. And some of them will be the same. Like we see that some nebulas are matching from one side to the other. Then we see that there's some globular clusters that are sort of different from one side to the other. So you can see what potential each sky holds as you look further and further into what's up this week. That's a great opportunity for you. But as we've sort of explored the southern sky in more detail than we've had an opportunity to lately, do you have maybe any last sentiments, Bob, about this sort of new perspective that not only this new sky it gives to us, but looking at this new stellar system and what it may tell us of our own youth and our own past?
Well, it's gorgeous. As I said, it brings to mind Saturn because it's a ring. It brings to mind birth and gives us a nice feeling that other stars seem to be being born in disks, protoplanetary disks, just as our own sun is believed to have. But it also has brought our attention, just as you've said, to the Chile telescopes. We haven't used that for a while, and it's great that we have these fabulous instruments in both hemispheres because each offers fantastic objects to see. I just love looking at that region that this is found in, the Scorpius Sagittarius area of the sky. Some might vote that Orion is the finest of the 88 constellations. Others would say that it's Scorpius because it really does look like a scorpion. And just to its left, there's the famous teapot shaped object of Sagittarius, which really looks like a teapot more than an archer, but it's right there. And some of the greatest objects, although we can image them from Canary, they are rather better seen because they are southerly from Chile. So it's nice to nice to use both telescopes.
Right, right. Yeah, we have both hemispheres. We might as well use them. It's been a great adventure tonight, Bob. Thanks for joining me on this trip through the sky, and of course, SLU members, thank you so much for tuning in and watching this show, watching us talk about what's new and exciting in the night sky. If there's anything you want to see, let us know. We have our live show page where we love to interact with you and hear what you're curious about, what you'd like us to talk about on certain subjects. We're all ears. We're here to hold these live shows for you and to explore the universe with you. So thank you so much again. And well, we're going to be back on very soon. We're just a couple days away from a very exciting planetary event. So do stay tuned. But for now, this has been Eric and Bob for SLU. We'll see you again.
Good night.
SLU astronomer Bob Berman, and we're going to go deep into space and see what's out there that's like us and unlike us. So, welcome, Bob. Thanks for joining us tonight.
Oh, it's a pleasure. So exciting to be here when we've got all the telescopes firing and a great night and amazing object in view. This is, wow, it's exciting.
Yeah. So, where exactly are we looking today? We have here's our all sky, but where are we going to be pointing tonight?
I know this was so funny. Before we were on air, I was looking at this. I know the sky pretty darn well, and I was saying, "What? What's those bright stars on the left? What is that?" This is. It's like I'm 8 years old and I'm starting with astronomy all over again. And then Eric said, "This is the southern hemisphere view. This is Chile." So instead of our all sky view from the Canary Islands in the northern hemisphere, we've got a Chile all sky, which means that right in the dead
Hello, SLU members, and welcome to the latest Clubhouse show. I'm Eric Edelman, the producer here, and I'm coming to you live from Smoky Hollow Studios at SLU HQ in Washington Depot, Connecticut. But tonight, we're looking at a point in the sky from a place on Earth that's a little bit different from where we've usually been going. We've been in the northern hemisphere with the Canary Islands, but now we're traveling south. So this might be a unique sky view for people that have seen the recent shows. We're going live from the SLU Gillescopes to look at a very, very, I say unique, but interestingly similar to our own stellar system. And so that's going to be a lot of fun tonight, and we might as well get started. Tonight I am joined